Alright guys, settle down, settle down. It's time to get started. Let me do this right now. This is the practice test. The test is taking place when? In a week from today. Yes. So, holy crap. So on Monday, I'll have an answer key for this. Monday's going to be pure review. We're not going to do anything new. We're just going to review the hell out of everything we've gone through. Get ready for the test. Let me do this. Judging there. It's a pure observational statement. I didn't say. This is just a practice. There's nothing we're doing right now. Let's see. Got a couple things to get back. Bonnie. Joe. Amy. Cross. This to him. Hillary. Augusta. Marlene. Garcia. Marlene. Karen. Giselle. Sasha. Stephanie. Daisy. Aaron. Sue. Aaron. Brandon. Okay. So I want to start off, as always, with any questions anybody has on homework or what we did last time. Last time we made it up through 3-2, and we did a little tiny, barely intro into 3-3, if I remember correctly. So any questions from homework? Are you guys doing the homework? Okay, that's helpful. All right. You guys doing all right? Is your weekend okay? I mean, not a weekend, but I mean Monday. What happened Monday? The Chargers won. You guys care about football? Yeah. Yes. I've always sort of liked the Chargers even before I moved here, so it was easy for me to continue rooting for them. I'm a Dolphins fan actually, which used to live in Miami, so it's been kind of rough. If you don't care about football, that's all right. I won't talk too much about it. All right. So no questions on. I always try to not let that scare me when there are no questions. I'll let that. I'm an optimistic fool, so that means everybody's doing great. The homework, okay? So we're gonna get right back into it. If there's no questions, there's one thing out of 3-2 that I always sort of forget to go over before I leave that section. And this is on page 92. And this is sort of what I was talking about when I pointed out that one situation the median was bigger than the mean, and we also talked about what it means when the median is smaller than the mean. Bless you. So if I have something like this, or something like this, or I mean there's a ton of these I could kind of do. What's one key thing about this? So here's one example. Here's one, and here's something that's different. That's definitely different, right? So what's different between this guy and this guy? What's kind of the main, obviously?
The first one has a more normal distribution.
All right, cool. This is normal. But now it's even not just normal because it's saying that this has the same property I'm looking for. That has the same, well, sort of, make it a little bit better. And this might give it away. So what am I trying to be careful about there? Symmetry, 11. So these are all symmetric. Cool. These are examples of symmetric distributions. This is obviously not symmetric, and we would call this one skewed to the, what do you think? Right. So skewed to the left, not surprisingly, would look like, oh, not like that. So that would be skewed to the left. Okay, cool. A very quick little thing. So when you could describe histograms a little bit more. If it's not normal, you could say, well, it's almost normal, it's just skewed a bit to the left or skewed a bit to the right. It doesn't have to be any of these, obviously. I mean, once you draw a distribution, it could look like who knows what. But sometimes they will have symmetry, just like graphs in math have some symmetry to them, like a parabola, symmetric. Okay, so nothing major there.
You never went over from 3.2, like those weird, they're kind of like weird formulas. They're, like one of them's to find the mean from a frequency distribution, but the one I had a question on was like the weighted mean.
Yes, cool. And I'm not going to talk about actually the frequency distribution one,
Okay.
but I will take a question about the weighted mean. That's a question I expect. So there are certain questions in the homework. Sometimes I will tell you, I purposefully don't talk about something because it's in the book. Maybe it's a little definition, maybe it's something that's not that big of a deal, but it's in the homework for two reasons. One is if I don't get that question, I'm worried. Nobody's done it yet, or nobody wants to tell me about what the hell's this. And secondly, just so that I force you to look through your book. Right? Because a lot of us, the only part of the book we ever see is the homework part. And that I don't understand. And you should love it when you still have examples in your books. Oh my God, whatever you're going to go into, as you get further along, there's going to be fewer and fewer examples. If you're in math, a few math courses down the road, there's no examples. There's theory, 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 and then 20 problems out of nowhere. Holy crap. But that's one reason why I do that, is to make people go back through the book. But how do you find, like in my class, let's trunk it down a little bit and make it easy. Let's say that 50% is tests, average. Let's say 20% homework, and 30% is the final. It's not really mine, but it's kind of like mine. If you knew those three grades, how could you figure out your average in the class? So let's say you made your test average is 81, your homework you did really well on, and the final was a rough day. How can you figure out your average? You're just going to sit back and take what the teacher says and not even check that? Hell, believe me, you want to check it. Yeah.
You can put that over the percentage as a number, and then multiply it by x over 100, and then add them all up.
I sort of followed you. So put like 81 over this?
Yeah, over 50, and then do x over 100, and then
I see.
multiply.
If they were all equally weighted, let's start there. If they were all the same weight, like it was 33% and 33 and a third percent, 33 and a third percent, 33 and a third percent for all three of them, how could I find the average?
Divided by 3.
Yeah, add them up, divide by 3. So the only thing is, ever cool that is you'd find the same way. If they're all equally weighted, they all matter the same, then you throw them all in so that you just average them, take the average. So why can't I add them all up and divide by 3 right now?
They're not worth the same.
Because what's the most important grade up there? The tests, right? That's 50%, it's half the total grade. You guys sort of with me? So here's how you do this. 50% of your grade. So 0.5, 50% of your grade. So 50% of the 81 gets put into the grade. And everybody know that of means multiply? Strikes me that people coming out of high school nowadays, they don't get taught that, or they forget easier than they have in the past. Of means multiply. So 50% of 81. So the grade, your final average, is going to be made up of half of this piece, plus 20% of that, plus 30% of that.
Simpler.
How are we doing so far? Is that cool? So, I mean, when you have a teacher that does points, well, that's easy enough to tell where you are, because if it's 500 points for the midterm and you got 250 points, you got a 50 on the midterm. You can make your own little percentages. You'll never catch me doing it. I just don't like doing it. And what do you guys get here? So it's 40.5 plus 40, no, not 48, that's not half of that. 0.2 times that is something, 19.2, plus whatever the hell that is, 20.1, yeah. So you get 79.8. And that's where you come see me and say, Jeff, man, I got some tutoring. Can you bump me up to a B minus? Right? 79.8. It's like, come on. So I can understand that. Huh?
Do you round?
No, but I do factor in, I can see how often anybody's gone for tutoring. I can see how many corrections you've made, which is sort of like an effort grade. I know who's come to my office hours, you know. That all gets put into the fudge factor in the end. So if you got a 79.8 and you didn't do any corrections, you didn't go to tutor any time, you never came to see me in my office, you got a C+. Because that's what that is. If you came to see me in my office, went to the tutor a few times, you did corrections, you got a B minus. You see how that works? And that's how most teachers really operate. So even though I don't expressly give you an effort grade like you used to get in first grade, that still factors in.
Effort grades in high school.
High school?
Yeah.
Really?
Yeah.
Of course, I've seen people, I used to do transcripts. When people came into the college where I used to work, I would do the transcript evaluation so I could place everybody in the math course. That was me. And somebody got a grade for lunch. And it wasn't an A. Like, you miss your mouth sometimes. A drinking problem. Yeah.
Yeah, we got an effort grade and a like behavioral grade as well as our grade, which I figured would be the same thing as effort grade. And we had 3 different ones.
That's amazing. I'm going to start doing that. Behavioral grade. He was annoying, so he gets. Real quick, I want to kind of prove this to you. So, like I said, if these were evenly weighted, then you would add them up and divide by what?
3.
So can't I write this as 1/3 of 81? Is that so far so good? Right? I'm a total math geek, so sure, Jeff, if you want to do that weirdness. Isn't that the same thing? 1/3 of 81 plus 1/3 of 96 plus 1/3 of 67. Isn't 1/3 33.3 forever percent? And so you see how I'm doing the same thing? It's just that here the percentages are not even. So I got to multiply by whatever that percentage is. So which one of these grades, of course, ends up having the most influence over this? Well, the one that's got the highest weight. Of course, when they're all evenly weighted, the math is easier, but actually if you forced it to kind of go this weird route, you could see the math that you have to do here. Okay, cool. All right. Just one problem like that. I like to throw it in there because that's how I do my class. I wanted to see, does anybody realize how to get their average from a class like that? Okay, cool. So I feel a little better. At least one of us has hit that problem. Okay. So any other questions on that there?
On the bottom, where did you get the 0.335?
333. Sorry. It's a 3 with a little, repeating. Yeah. Yeah. Cool. All right. So let's get into section 3.3. And you guys might remember what I said last time. This is like the most important section we've hit yet. And this is a huge player
in chapter 6, which is the most important chapter in the book. Sense of theme here. And this is all about the spread of data. So like we talked about last time, if you know the average of something, that's good. That's kind of like a good summary of the data, but it's not good enough by itself. If I could just get a number that would go along with that, that would tell me how spread out the data is, that's an awesome summary. Don't give me all 800 data points. Just tell me the average and this number, and I kind of get a feel for the data. Cool, so that's the idea. Let me give you something that's a little less mathematical, a little more closer to home, because you guys all know, you might know this. I know you know about the website Rate My Professors, right? And I loved it. When I first heard about that, when I worked on the East Coast, they told the professors about it, and the next day, everybody had written their own review. They all went in there. He is the essence of the essence. Oh my God. So I found that really funny. But I don't know if you guys know, there's another website that you can actually find the grade distributions of your professors over the years. And unfortunately, what happens is a lot of people find that, and they see the people that give nothing but A's. They take them, and then they suck in their next class. Right? So I'm having that problem right now in my pre-calc class. A lot of people took the 110 guy who was really easy. They're now coming to see me, and I am not quite that easy. So too bad. So be careful when you look at grade distributions. What do you really want? So let's do an example. Let's say I know there's two professors. They are both the same, basically, personality-wise, whatever else you might care about. They both give an average of C to their classes, right? But one person, the spread of their grades, they give only up to a B and only down to a D. So they don't fail anybody, but they're waiting for God to take their course to give an A to. Right? And I've had professors like this. Right? Never gives out an A. Then there's a guy who gives a C also average, but he gives from A to F. So his spread is larger. Right? So if you know the average of a C, that's not enough. What's the spread of the grades? How likely is it that I'm going to fail? So which one would you rather take if you knew you were going to kick ass in that course? The one that actually gives A's. Because believe me, I kicked ass and got a freaking B. I'm still there. So which course obviously would you take if you thought you were going to suck major? Especially if you're at university, because D's here don't mean crap. But once you're at San Jose State or somewhere you've actually transferred, D is pass. D is fine. As far as you don't have to take it over again, but which one would you rather take? Obviously the one that doesn't fail anybody. So in that case, that's a really simple example of why it's important to know the average and the spread. The average by itself is not good enough. Another example is a little less exciting, is a little less relevant, I guess, is if you wanted to get certain size parts for a machine. So it's got to be really close. It's sort of like that problem you have with this 0.75 inch screw or whatever it was you had to make a histogram for. Some of you guys are nodding your head, some of you guys are. And you go to one manufacturer and they say, yeah, we make an average of 0.75 inches screw, give or take 0.1 inches. Right? So that give or take, that's kind of like the spread, sort of. It's related to the spread. And you go to somebody else and they say, yeah, we make 0.75 inch screws, give or take 0.5 inches. Right? That's crazy. Let's say 0.05. So the first guy, give or take 0.1. And the second guy, give or take 0.05. So obviously, who you would go to? Who would you go to? Yeah, the 0.05 one. So that's, I just want you guys to realize this type of stuff we're doing is immediately obvious as to why it makes sense. This is what I'm hoping. Why would we want these stupid numbers? Well, because I can then make decisions. And we see this kind of stuff all the time in the real world. In newspapers, they talk about it in the news, they talk about all this stuff. Tell me, I can't give an example, but I think last time, what was it I put up here? 5, 5. Somebody get that written down from last time?
3, 4,
5, 5, 5, 5. 2, 3, 4, 5, 6, 7.
1, 2, 5, 8, 9.
1,
2, 5, 8, 9.
2, 5, 8, 9. And then I put another one up here.
1, 1, 5.
Yeah. So this is what I was trying to discount the idea that the range would be good enough. The range here is, what's the range on the first one? 0. The range here, 4. 7 minus 3. The range here, 8. So far it looks like the range is doing a good job of differentiating, but the minute it gets here, the range is still 8. But these two are certainly different. Which one is more spread out? Yeah, this is kind of a weird question because people don't realize this is the more spread out one. And what do I really mean by spread out then? I mean who has data points that are further from its center? You with me? Because why is this not spread out at all? Because everybody's right in the center. So therefore, that must mean we're intuitively saying distance from center is sort of what spread means. So which one is the most spread out? This one. Its data points are furthest from its center. Cool. How are we doing? And be careful, I don't mean center. In this case, of course, the median is also 5. But when I say center in this case, I mean the mean. It just happens to also be the median. Okay. So, here's what we're going to do. Some of you guys are going to check out on me early, and I understand to a point, because this gets a little bit. But I want to show you where this formula comes from. One reason why I love statistics is stats is very practical in terms of it uses math to achieve a goal. It says, all right, I need this. Math, what you got for me? I need something that does this. Let me make it do what I want it to do. And you can see it happening. It's kind of nice. So it's not so much math on high saying this is the way it is. It's I need to do something. What do you got for me? What can I use that you got? So to get the spread, let's first look at, not this one. This is not very interesting. Right? The work there would probably be pretty simple. Everything's zeroed. Let's look at this one. So where's a good place to start, since this number should somehow capture how far away everything is from the center? What should I first calculate for each data point then?
How far away from the center?
I love it. Good place to start, right? How far away from the center is everything? And let's say, let me do this. Let's see. I'm going to first do this as if it's a population. And then I'm going to do it as a sample, because there is a change based on which one it is. So I'm going to first treat this as a population. And then I will change it over and treat it as if it's a sample. Right? This could be a population. Our population could be this big. It could be these numbers in a hat. I'm going to pick out of it. So my population is these numbers. So the mean in this case, of course, is 5. Oops. So which symbol should I use there? Already.
X the line.
No, that's for a, what's the X bar? What's that for? A sample. What is it that I use for the population?
The mu.
The mu. I love it. Okay, cool. Not a major thing, but I want to be consistent. So what, of course, what do I get here then? X minus mu, -2. And then here, -1, 0, 1, 2. Okay, so nothing major there. The negative here sort of tells me which direction it is from the mean, right? Negative is down, positive up. Yes, ma'am?
Where does the 5 come from when you did 3 minus 5 equals -2?
Yeah, the 5 is the mean. I use samples stuff here because I was originally considering I just go right to the sample. But I want to treat it like a population first. So this is our mean. Cool. So it's just taking the average of these things here. And let me kind of get us used to how to work with this table, because we're going to see these tables a lot. Trust me. If I add these up, what symbol could I put here to denote what I just did? Yeah, that big old sigma.
Okay.
So add up the x's, and of course, when I add them up, what do I get? 25. So the mean would be the sum of those x's divided by n, and that's where we get 5. Oh yeah, sorry. I keep thinking sample in my head. Okay, cool. Are we all doing semi-decent? So nothing ground shaking yet, I'm hoping. A couple things I want you to realize, how this table kind of gets set up. All we've done so far is what makes sense. We want this number to tell us, on average, how far the data points are away from the mean. So it only makes sense, the first thing I'm going to do is, how far away is each one? Because then how do I take an average distance then? How do I take an average of how far away they are? How do I take an average of anything? Add them up, divide by how many there are. Now what's wrong when I add these things up?
Average 0.
Get out there. Shit. And can anybody realize no matter what data I use, this will always add up to be 0? Because there will be equal amounts negative as there is positive. Always. Some of you guys might be enough to realize the mean isn't always going to be right in the middle like the median is, but it's going to be in the middle value-wise. So if there was, there's going to be equal negatives as there is positives. So there could be a lot negative and then the last positive is huge because it's like a real big outlier. It's always got to be 0. The mean is right in the middle value-wise. So of course if I subtract the mean from everything, it's going to have equal negatives, equal positives. Cool. So this column kind of sucks. So you're like, good job, Jeff. Thanks for taking us down this road. But what can we do? There's two things.
Absolute value.
We could do absolute value. And we're not going to. And I'll tell you why. What does an absolute value look like if you graph it? Anybody know what letter of the alphabet?
V.
V. I can't put those together. So V. There you go. Right, it looks like a V. That's a U script. Why does it have that sharp edge? What looks like a U? Parabola, and that's an x to the second power, any even power. And that's of course nice and smooth because it's not straight lines. It's a square. Anytime you have something to the first power, it's going to have to be a straight line. But if I take the absolute value, can it go negative? No, so then it has to turn. It has to take that sharp turn. We don't like sharp turns in mathematics. It's not like we don't like it. Math doesn't like it. It's a very abrupt change. So the absolute value would help us here, right, wouldn't it? Because it would kill all the negatives. And in fact, absolute value is actually based on distance. But it has that issue with having a sharp turn. So what's something else we could do with this that would make it come out positive? Square. So if we square all these numbers, they're going to come out positive. What do we have to do at the end, though, to bring it back to normal? Because if this is number of TVs, and I square it, now I have number of squared TVs. What the hell is that? So at the very end, I have to square root it. So let me make sure everybody's with me. Why are we squaring these numbers right now? Because they're negative. That sucks. They have to be 0. That's not very useful. Everything's freaking 0. That's not good. So right now, we're going to square these bad boys. Yes, sir?
Wouldn't that just be the same as making an absolute value?
No. Again, squares have a very nice, continuous shape to them.
But then you said we had to square root them at the end, right?
We have to square root them at the end.
So, unless I'm forgetting something, that would just bring it back to the original number without the negative, like it absolute value.
Not quite, no.
Yeah, so wouldn't that mess up the result?
No, because what we're going to do in the middle of this, we're not going to take the square root of that directly. We're going to take the square root of the numbers we get at the end.
Oh.
We're going to take the average squared distance, and then we square root it. To get the true distance. Yes, sir?
So like if you get 3 minus 4 minus 3, or 3 minus 4, and you get -1, but you square both of them, that'd be 9 minus 16. That'd be.
No, careful. No, careful. This should be -1 squared, which is 1. This is not 9 minus 16, right?
Oh, okay.
Yeah. Okay. Cool. That square can't distribute through there. All right. So what do we get when we square each of these? Here we get 4, 1, 0, 1, 4. Okay. And of course, when you add those up, what symbol can I use to denote what I'm doing if I'm adding these up? Sum of what? What are these? I like it. So it is 10. But what do I put here? What did I just add up?
XU.
x minus mu squares. So the sum of these is 10. Cool. So this symbol, whenever you see this, you don't substitute into x and you don't substitute into mu. You need a list of these. You need a list of these so that you can add them up. That's the point I'm trying to make right now. You can't just substitute x in there, because what is x? A bunch of stuff, right? So I can't put a single number there. I need a bunch of these numbers, so then I can add them up. Okay, so far so good. So what do you guys just tell me? To get an average squared distance. I'm desperately hoping you're kind of with. To get the average anything. If I took everybody's age, how would I get the average age? Add them up, divide by how many they are. So what do we have here? We have a list of distance squares, right? Squares of distances. We had to square to get the negatives out of there, so we're cool with that. How do I get the average square distance? Add them up and divide by how many there are. The book probably has a big ass head. I don't care. And it's the same. So what do we just get for this? 10. And what's n? 5. 2. Now what's not quite right about that number yet? What did we just say earlier that we have to take care of? It's the square of what I want. So this number right here, this average square distance, is called the variance. Let me just say this right now in case you guys are getting very lost in the details. I always try to keep it. I know there's a lot of little details, and actually you guys are asking more detailed questions, and I love it. I need that. I don't want everybody to get lost in the details. What's really going on here? How far away are things? I had the square to kill the negatives, and then I take the average. Add them up, divide by how many they are. That's like the average distance. The symbol for variance for a population, you're going to love this, is the lowercase sigma. Get ready. Here's how you draw it. You start with the belly, bam. You don't draw the other way. You start with the belly and you go, bam. You don't have to say bam. It's like emerald math. And it's not quite there, it's squared, because that's going to tell me that I haven't square rooted yet. So the variance, sigma squared, is 2. So how do I get the actual number that I want? Square root. So sigma is the square root of sigma squared. Square root of 2, 1.414, blah, 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 blah. Yes, sir. Okay. Let me say this right now. I'm gonna talk somebody very slowly, so this is a major note. Standard deviation, which is what we just got. The standard deviation, always take it out to at least 3 decimal places. Let me say it even better. 3 non-zeros. So if you have like 0.000007, you don't round that to 0. Right, you go out to get 3 non-zero numbers in case it's really crazy small. You guys semi with me?
Is it called variance or is it called standard deviation?
So what's the variance? That's before I've taken square root. All right, so the variance is sigma squared. That's the variance. The variance right now is like a middleman. It doesn't mean shit to us right now. It's just I haven't taken the square root yet. It doesn't mean anything to us right now. We'll see later in the course that it's actually useful to do some other more advanced things. Right now it doesn't mean anything. It's just a middleman.
Okay.
Standard deviation is the number I really want, and that's sigma. Because now I've taken the square root, the square goes away. All right, semi-decent. Some of you guys look like you want to kill me. I understand. Nobody laughed. Now I'm a little worried. Yeah, Jeff, basically.
It's always round to 3 non-zeros?
Yes, exactly. Round, don't just cut. Did I just cut that? What is it, 1.414? Somebody do the square root of 2 for me? They'll trust me.
1.41421.
Cool, yeah. I just had to remember that, so, you mean, I can't do square roots, don't say 2 square root
So
of
you
1
just
now.
call it 1.414?
Yeah, 1.414. At least 3. If you want to go a few more, that's kick-ass awesome. If you want to use your memory button in your calculator and do it, that's way sweet. But if you want to round it, you have to do at least 3 non-zero places.
So if there's zeros, you wait
Yeah,
till there's
so if you got like a variance of, a standard deviation of 0.004179, you wouldn't round that to 0. You round that to 0.00000418. You with me?
Okay.
Yes, sir.
Now you don't need to do that if you get like a whole number, right?
Exactly. If it's a whole number, you can if you get 8, exactly 8, you don't have to go, all right, Jeff, well, it's 8, it's fine, right? You with me? Yes, sir.
Can I do another example of the
Oh,
population?
hell yeah. Actually, let me, we've got all the work up here. If it was a sample, and let me say this real quick. I've got a handout where I've got one side of it is a worked out problem, and the other side is going to be, if we have time hopefully, something I want you guys to do, maybe in groups if you want to work together, doing a problem like this on your own. If it was a sample, we'd obviously not use mu, we'd use x bar. That's not a big deal, it doesn't really change the calculations, right? These are both just means. It wouldn't be sigma squared and sigma, it would be s squared and s. Does somebody remember about the Greek letters? And they seem really important, so we use those for populations. For samples, we always use our letters. So the mean is x bar, standard deviation is s, right? Because this is the Greek letter s. Cool. And the real big change, now here's where it's going to take a little explanation. The real big change, population variance is this. Sample variance, this is going to change just a little bit. And let me try to explain. And this is where I'm sure a few of you guys have checked out. I almost can't blame you, but if you're in this class, you probably want to pay attention. Let me desperately try to do this. So right now, there is a true average age in this class, right? Yes, okay. So there's an average age of people in this classroom. If I took the average age, and I took everybody's grades, and I did what we just did, not grades, but ages, and I did what we just did, I'd get a standard deviation. It'd be a sigma, because this is my population. Now, and that's based on what is everything being subtracted? X minus the true mean, right? The mu, the true mean of everybody. If I take just this row, and what kind of what sampling did I just do? You're all in rows. I took everybody in this row. Cluster, I love it. Very limited cluster, bad cluster, but oh well, too bad. Let's say I take everybody just in this row. Am I using mu to calculate things?
No.
No, I'm using their average, right?
Yeah.
And if I happen to pick a bunch of really young people, right, relative to everybody else, wouldn't their average age be smaller than the real average age, of course? So therefore, wouldn't their ages be closer to that? Let me say this again. Wouldn't their ages be closer to their average age than it would be to the average age for everybody? Let me say that one more time. Because I know there are people going, what the hell did he just say? Their average age would definitely be closer to each of their ages than their ages would be to the whole average for everybody. Cool, okay. Therefore, the standard deviation would be smaller than it really should be. Because they would be closer. The average distance would be smaller than it really should be compared to everybody. So, to correct for that, how do I make something bigger? Because if I just use this formula here, let me write it down, because the adjustment we make is very simple. If I just do this, that's going to be too small. Because this is going to be smaller than it really should be. They're going to be closer to their own average age than they would be for the average of everybody. Most of the time, not all the time. What do I do then? If I divide by n and I get something that's too small, I want to divide by something a little bit smaller to make the whole thing bigger. Let me say it again. If you divide by something, what do you divide by to make it a little bit bigger? The answer you get, you divide by less. Right? If you divide by a smaller number, you get a bigger number. So the funny thing is, you just divide by that. This is where you got to trust me, that there is some reasoning behind that. It's not something they just pulled out of their ass. Oh, we got to divide by a little less. Let's just subtract 1. I think right now I'm not going to try to get it in. That's actually going to come up later when we talk more about this n minus 1. But at the very least right now, I want you to understand why this at least sort of makes sense. It's an adjustment we have to make to this formula when we have a sample. Adjusting for the fact that all those averages will be closer to their own, all those ages will be closer to their own average. Okay, maybe. You understand a word I just said, use that formula for a population, that formula for a sample. Yeah.
Why are you trying to adjust it if you're trying to figure out what it is for the sample?
Because what we pretty much always do in statistics is we try to use this to estimate what the real one is.
Right.
So we have to do this to make that adjustment.
Okay.
Okay. Yes, sir.
So what if you get a sample where everyone's age is like represents the population, and then you guys do that?
This will correct it in the right direction for most of the time, not all the time. Because you're right. It's a random sample. Anything could happen, right? But this will correct it in the right direction most of the time. So that overall, if I did every single possible sample, and I took the average of those, it would be closer to the real standard deviation, the whole population. That's really what's coming much later in the class. That's where we're headed. Yeah.
I'm not sure if, and I think this is what I asked, but we can try a different way. If your sample was actually like an accurate representation of the class, that would still work.
Yeah, this would still be the formula, because you don't know which one it is. When I take a sample, I have to assume the worst.
Okay, but it would still be accurate?
Yes, it would still be what we use.
But it wouldn't give you the same number as the population?
No.
Okay.
Yeah. So where I'm really going is I want overall, every possible sample I could take, when I take the average standard deviation of all those, I want it to represent the real standard deviation. That's really what this thing is trying to go towards. So some samples it could make a little worse, but most of them it makes better, and that's why we're cool with this. If I stuck with this, most of them would be worse. Well, let's screw that. Let's go to where most of them are better. And actually, this n minus 1 is exactly what we need down there to make it the best situation. Now, I got a lot more into it than I ever have in any stats class before, to tell you honestly. And it gets a little bit murky. For anybody, I really want to keep it on the level of, all I want you to know about this n minus 1 truly is, it's an adjustment because it's just a sample. So we almost always have to adjust something if it's just a sample. And there's the adjustment I have to make here. So if I were to do the same stuff, somebody will help me out, remember those. We've already got most of the work here. The only thing I have to do, I can start right here. I won't use that. The variance would now be, so what do we get for the sum of the x minus, and here it would now be x bar. That's not a big deal. It's still 5. Still the same mean. So we got 10 for that, right? And what would n minus 1 be, of course? 4. So now I get 2.5. So this is if that data was sample data. This is the formula I would use, not this one. And what's the only difference between them? I don't divide by n, I divide by 1 less. So all the work we did is still fine. I just have to divide by 4, not 5. So what do we get now for our standard deviation? 1.581. Okay, so made it a little bit bigger. A little bit more true to whatever the real population is where this would have come from. So isn't that bigger than the other one was? And of course it is, because we divided by a little bit less. Okay, all right. So let me do this. Let me give you this handout. I want you to look over the front because it's got the example where I've worked it out. On the back, I want you guys to try to do this one. I've given you 8 data points there. Actually, before I do that, let me show you. Let me show you how to do this in the calculator. Because if I give you a list of 20, do you really want to be doing 20 subtractions and squares? And I wouldn't if I were you. If you need to borrow a calculator, they're up here. What's that? Yeah, so you have to show me your tables. What I'm about to do, though, is to show you how the calculator can populate the table very quickly. You just have to copy it down. Because I'm not going to grade you on you know how to subtract and square. Hopefully you made it here for the right reasons. So let the calculator do all that crap work. Right? That's what it's there for. Anybody else need a calculator? Yes. Sweet. All right. So here's what I want you to do while I'm getting this set up. Go ahead and put the data into list 1. Let's do let's do this one. And I'll show you, it actually gives you both standard deviations. Because when you put this data into the calculator, does it have any idea if it's a population or a sample? So it gives us both, and it says, you're the human. You figure it out. All right, give me 1 second. I'll put it on the right thing here. Okay. Yeah, the 3, 4, 5, 6, 7. I just want to show you that you get all the same numbers we got. All right, so let me catch up. 3, 4, 5, 6, 7. So here's the beautiful thing about this calculator. What do I want list 2 to be? Yeah, all those values minus the mean. And so you have to come into this knowing what the mean is. So you should have already calculated. We did. It's fine. So where are my x's? In here. Where are my x's? List 1. So here's the beautiful thing. And be really careful about this. Go up to list 2. Highlight where it says L2. And see how at the bottom now it says L2 equals what? So I'm going to tell it L2 is everything that is in shift 1 for L1. So I want it to be L1, all the stuff in L1 minus 5. Bam. So you can imagine if you had a list of 20 things, thank God. Especially if your mean is like 11.893. I really don't feel like doing every single subtraction, you know. So all you have to do in a test or a quiz or in the homework is you can put the data in here, copy it down from your calculator. That's fine. You still have to show me this work. But I'm not going to make you show me subtraction work. So what do you think I want to make L3 equal? L2 squared. I love it. So let me show you an error you can get doing this. Does anybody see what I've done wrong already? I've done something wrong. Yeah, it's going to tell me error data type. And you're going to think that it's insulting you or something. You hit go to and it says, here's where the problem is. I'm like, oh shit, I tried to put a whole list into one spot. So that's what it's trying to tell me. So I'm like, shit, all right, so let me not do that. Let me go back. All right, cool. Clear. Go up to L3. L2 squared. Bam. Okay. Doing all right? All right, here's the next thing. The next thing I'm supposed to do is, of course, add them up. And this is what I think I keep forgetting to add it to my little calculator Bible that I gave you guys. Hit second mode. That's second quit. That's an awesome thing. It always gets you out of whatever you're in. Second mode for quit. Now, do you see how above stat it says list? So hit second stat. And what do I want to do? I want to add this up here, right? So go over to math. And I want to sum, number 5, I want to sum. So you hit number 5.
How'd you get to that
Let
one?
me do it again. So hit second stat. So that gets you into lists. Hit over to math. You can see here's a bunch of operations I could do. That's interesting. Go to math. Is that cool? So second, sorry, do it again. So hit second stat. Now go over to math. And number 5 is sum. So hit number 5 for sum. And sum what? Sum L3, right? I want to sum the third list in. I want to get the sum of these things squared. And there's our 10. So it's a little bit lame, all this, if you have only 5 data points. It's pretty much quicker just to do it, especially with a beautiful mean like 5, right? But you can imagine if I had 12 and the mean was 3.18. I'd much rather have the calculator do all this stuff. Okay. So let me give you that handout.
Is there a way to like attach data to another data point? For instance, it's like 30 people make 30,000 a year, or 26 people make 25,000.
L1 is the first thing, the 30 and the whatever you were saying, the percentage of people. L1 is that number. L2 is the income, and you just don't sort them. You can then do two variable stuff. There's a whole two variable section where it will keep those together. It'll realize those go together.
Well, what if I want to sort them like by one of them?
Then use Excel. Yeah, if we had the money, and obviously we don't have any money. But if we had the money, we'd have more computer labs, and we'd probably teach our stats courses on Excel, because it would just make more sense. That's what's used in the business world and everywhere, Excel.
Yeah.
We just don't have enough money to do that, to have courses where we can have classrooms with computers, with Excel. So we have to rely on the TI calculator. But Excel could do that. So this is actually a handout that I just created this morning. I've never actually had a handout for this, but I thought, I have a lot of handouts for stuff later, but this is one of the most important little ideas. Sorry, what the hell, I'll make one like this. So the front is a worked out example, so you can reference it as you do it. On the back is the one I want you guys to try. So try to fill in that table. And I made it so the average comes out to a whole number because we're learning, but that's not going to happen to you in the homework. Yeah.
What is the z-score?
Oh, we'll talk about it.
Oh.
Don't worry about the z-score question. We'll get into that.
So for this, you have to put it in order, right? Or you just put
It doesn't have to be in order, actually, but it's kind of helps, especially when you have repeats. Then you can fill those in pretty quick. Yep.
It's like, so like when you put in the calculator and you do like L2, like L1 minus 5, is it always minus 5?
No, it's not. Why was it 5 for our example?
That was the mean.
because that was the mean. So it's always got to be x versus L1 minus whatever the mean is for that. Did I? Shoot.
You said minus
Sorry.
5 on there, but
I know. So what did I do? I copied this, put it there, and just erase things, and I just forgot. So don't put, take the 5 out. Everybody look at number 2. This is the dangers of making something right before class. Number 2b, see where it says L2 equals L1 minus 5?
Yeah.
Alright, so scratch out the 5. It's just 5 because I copied it from the first problem here. Alright? So that would be whatever your your average grade is. Whatever the average is for that situation.
is there a way to clear all the lists at once? Or
You can hit stat clear list, but then you have to list the lists with a comma in between.
Oh, the comma.
with a comma?
Yeah. So that's why I have a comma on your calculator. Above the 7 is a comma. Call me over if you need some help. I can do this as we talk about it. Cool. So you got the mean. So now 7 should go there. Yeah, the mean. Whatever the mean is for the situation, that's what I said should subtract. Good one, Eddie. Keep smart.
So you said don't worry about the z-score?
Don't worry about the z-score yet. I mean, you certainly can do the work. The math there is not difficult, so you can do it if you want to. But
I'm not there yet. I just finished writing them all down.
yeah, but it looks like
So
the
2.3905?
factors into these.
Yeah.
Well, yeah,
You
these
notice
only
how
go to the
this
third
doesn't really go
decimal.
with this.
Oh,
So not it won't change your numbers, but just be careful about that in the future because that prime will throw me off completely.
Variance.
But all your numbers will be fine. You add these.
5.714.
Yeah. And this, of course, you can do zeros. You can verify.
Yeah, it's really weird.
Okay.
So that gives you that sum
Because
thing.
I was doing it,
So,
I was doing it as if you like.
so these
I don't know
change?
if
Is I
you
don't
like-
understand it at all.
Yeah,
like, I
when
just
you
think
sort one list, it
it's-
leaves everything else the same.
Oh,
That's what somebody was asking. Of course, when you do Excel,
That's
you
what
can
I learned.
change the range, but
I learned
you can't do that with
math.
this.